Hey guys, I'm up for jury duty, so I've made this video to help you complete your velocity versus time graphing challenges. First thing you should always notice on a graph are the units given. So we have velocity in meters versus minute on the y-axis, and the time axis is in minutes. And we want to describe the acceleration from 40 to 55 minutes. So that's from 40 to 55 minutes. That's from here to here. And actually I can get a different color. I'll leave it as blue, that's okay. So from here to here, I want to get coordinates for this point and this point. So the coordinates are 40 minutes, my x value, comma, negative 40 meters per minute for the y. Up here, the coordinates are 55 minutes are my x value, and 0 meters per minute are the y. Okay, so let me see, I have a marker. This is my x1 value, this is my y1 value, this is my x2 value, and my y2 value. Acceleration is the slope of a position versus time graph. So you need to put this in your notebook. I'm sorry, is slope of velocity versus time graph. Put this in your notebook. You need to have this memorized. So we're going to calculate the slope. Slope is change in y. Slope equals acceleration. And that equals y2 minus y1 divided by x2 minus x1. If you do this in your calculator and you don't put parentheses in both the numerator and the denominator, you'll get it wrong. So be careful. So I have the y2 value is 0, minus the y1 value is negative 40, minus a negative 40. Close my parentheses. On the bottom, I open parentheses. x2 is 55, minus x1 is 40. So I simplify, it becomes negative 40 over 15, and the units are meters per minute divided by minute. I can simplify this further. If I divide negative 40 by 5, I get negative 8. If I divide 15 by 5, I get 3. And the units are meters per minute squared. This is my answer for Graph Challenge 1-1. All the units for acceleration are distance per time squared. Distance per time per time. So then we want the displacement during this time. Be careful. Displacement on a velocity versus time graph is the area under the curve. You need to memorize this, write it down. So I'm going to draw out the area for you from 40 to 55. Be careful. A lot of students will mark out an area that's not right. The area under a curve is always trapped between the x-axis and the graph. Always trapped between x-axis and the line graph itself, or the curve, but we're dealing mostly with straight lines, so it's always trapped. So I'll mark out this area, I'll shade it in with my highlighter. It's not out here, it's not up here, it's between the line graph and the x-axis. And this is a triangle. We're going to be dealing with very easy shapes, just triangles and rectangles. The area for a triangle equals 1/2 base times height. If this was a full rectangle, it would be base times height, length times width. But in this case, I have half of that. So I'll plug in 1/2 times my base, going from 40 to 55 minutes is 15 minutes, times my height, My height is negative 40 meters per minute. My minutes will cancel, and I'm left with a displacement of negative 300 meters. It's negative because velocity or displacement is a vector, so I can have a negative value. Now some students were having difficulty with this from 10 to 15, I'm sorry, with number 2, what is the displacement from 10 to 15 minutes? In this case we don't have a triangle, we have a rectangle. So it's this space here. Make sure your areas are trapped, and I do want you to shade them in. I have colored pencils you can use. The area of a rectangle is the base, which from 10 to 15 minutes is 5 minutes, times a height of 60 meters per minute. So that's how you'll get the displacement for 3, 2. I hope you found this video helpful. Thanks for watching, and study well.